This is the classwork from today that we asked you to complete to review for tomorrow's quiz. I just wanted to go over the answers with you in case you have any questions. For the first one, they want you to find the distance between 2 points. So we're going to use the distance formula, which is written right above the question. So we're going to substitute in. I like to go ahead and mark the coordinates. This way, if I mark them, x sub 1, y sub 1, and x sub 2, y sub 2, I know exactly where I'm writing them in the formula. So my x sub 2 is 0, my x sub 1 is 4, so I have the quantity of 0 minus 4 squared, plus my y sub 2 is 1, minus y sub 1, which is 2. And the distance formula requires that we take those values and we take their square root. All right, so 0 minus 4 is 4. 4 squared is 16. 1 minus 2 is negative 1. Negative 1 squared is positive 1. So I have the square root of 16 plus 1, which means this has a distance of the square root of 17 units. Okay, we're going to do the same thing for question number 3. The first thing I'm going to do is label the coordinates. Again, I'm going to use the distance formula. So we have x2, which is 3, minus x sub 1, which is negative 1, squared, plus y sub 2, which is negative 4, minus y sub 1, which is 3. We have to take the square root of that value. So 3 minus negative 1, you could say it's 3 plus 1, which is 4. We know that 4 squared is 16. Negative 4 minus 3 is negative 7. Negative 7 squared gives us 49. So we have the square root of 16 plus 49. So we add them together, which would give us the square root of 65. So our distance is the square root of 65 units. We can leave it as a radical. They didn't ask us to estimate, so we want to leave it as an exact answer. For question number 2, since I did 1 and 3 first, for question number 2, they ask us to find the distance from the point 42 to the line y equals negative 2. So I included a diagram here that I just made on Desmos graphing calculator, and I plotted the point 42 and the line y equals negative 2. So if you recall, when we were in class, for the problem of the day today, we dropped a line straight down from the point on the parabola right down to the directrix, and that's kind of like what we have here. You can see from the diagram, we're just looking at the change in the y values because our x values are not going to change. So if we just consider the y values, we can subtract them like we did today when we were coming up for the equation for this line. What we did was we said take the y coordinate, which here is 2, and subtract from it the value of the directrix, or this line. So we're going to subtract from it negative 2. So 2 minus negative 2 is 4, which makes sense because if we look at the x-axis, the point is 2 units above the x-axis, and the line is 2 units below the x-axis. So the total distance would be 4 units. And we can do the same thing over here for question number 4. We can simply take the y value of the point, which is 3, and subtract from it the line. So 3 minus 5 would give us negative 2, but since we're talking about a distance, that distance would be 2 units. Okay, so we're going to take a look at question 5. Derive the analytic equation of a parabola with a focus of 1, 3. Okay, so we know it has the focus at 1, 3. That's this point right here on the graph. Okay, so the directrix is y equals 1. That's this line right here. It says use a diagram to help you work this problem. All right, so A, label a point x, y anywhere on the parabola and label it x, y. Okay, so I did part A. Part B, write an expression for the distance from this point to the directrix. So they want us to find the distance from this point down to the directrix. Just like we did it for problems, probably problem number 2 and problem number 4 above, we can do the same thing here. We can say what it's going to be is y minus the value of the directrix, so y minus 1. Part C. Okay, so we're done with part B. Part C. Write an expression for the distance from the point xy to the focus, 1, 3. Okay, so if you remember, it's x minus the x coordinate squared plus y minus the y coordinate squared, and it's the square root of that entire sum. Now we have the two expressions. This is going to represent the distance from the point xy over to the focus. So now we can apply the definition of a parabola to create an equation in terms of x and y and solve for y. So we're going to set the two parts equal to each other. Y minus 1 is equal to the value we found for part C. In order to solve, just like we did in class, we're going to have to square both sides of the equation. So on the right side of the equation, the squared cancels out that square root. So I can expand the quantity of y minus 1 squared. That will give me y squared minus 2y plus 1 is equal to, and I'm going to expand the quantity of x minus 1 squared. It'll be x squared minus 2x plus 1. When I expand the quantity of y minus 3 squared, we get y squared minus 6y plus 9. Our next step would be to combine like terms. I'm going to add 6y to both sides of the equation. I'm going to, this cancels then, I'm going to subtract 1 from both sides of the equation, so it cancels over here. And that should bring my y terms to one side and my constant and x terms on the other. So on the left, I have 4y, and on the right, I have x squared minus 2x. Those cancel. This is gone, plus 9. The last step to isolate the y would be to divide everything by 4. So I'm going to write over here just so I have more room. We get as our final answer, y is equal to 1/4 x squared minus 1/2 x plus 9/4. All right, guys, good luck on the quiz tomorrow. If you have any questions, make sure you send me an email. If you're watching this early enough, you can come drop by the additional office hours today from 4 to 6 or with Miss Gallo from 7 to 9.